Good evening, viewers. Welcome to tutorial series on various interesting structural engineering topics. Today we are going to discuss about one very important topic, that is cracking of concrete. This is a very vast topic, and truly speaking, there is no coursework which when we graduate, that there is no elaborate training or no elaborate no understanding of this cracking has been taught, and that's why always this cracking of concrete is always seen as a panic, and a lot of reaction comes on whenever any cracking is there. Cracking, there are number of different types of cracks are there. We are going to see in this tutorial. There are certain permissible cracks, there are certain limits, and there are certain beyond. There are different times of occurrences, there are different reasons behind that, and not every crack is a structural failure crack. At the same time, it is also very important to look why the crack has appeared, and if anything serious is there or any distress to structure has happened, that need to be looked into. And also the cracking has effect on the durability of the structure, so from that point of view also cracking should not exceed the permissible limits. So that's all today we shall discuss. The topic is very vast, and I suppose I will be requiring around 6 lectures to thoroughly discuss this topic. Concrete is a very durable material, no doubt, and but we see the distress manifestations, and there are many reasons. We see these distress manifestation in the fresh concrete, we see it in unhardened state or in the hardened state also, that is observed. Why concrete cracks? The very basic reason behind why concrete cracks is it has a very good high compressive strength. 28-day compressive strength you can achieve from 20 MPa to 100 MPa and even beyond that. But it is very weak in tension. The tensile capacity is just about 10% of its compressive strength, and that's why when any tensile forces are developed within the concrete or even on the surface of the concrete, then there are chances of cracking increases and the cracking appears. So let us see what are the sources of tension in concrete. The sources can be external structural sources like gravity loads, wherein you can see the dead loads and live loads. There can be lateral loads, wind and seismic. There can be loads from subgrade settlement or swelling. Now what about internal mechanisms? Volume change restraint due to temperature changes or drying shrinkage. Concrete want to dry, shrink, but you have fixed it in a particular fixed volume. So naturally what will happen, whatever is the deficit of volume, the cracks are going to appear. Expansion due to corrosion of reinforcing steel or deleterious chemical reactions, that is also one of the reasons. We have a broad look. We first try to see the crack classification. We try to understand, because it is very important to understand that whatever cracks are observed, they are of what type and what is the reason behind that. So broadly we can divide them into two categories: cracks occurring before hardening and cracks occurring after hardening. Now cracks occurring before hardening, mainly you can divide them into two types: plastic shrinkage and plastic settlement. Of course there are other reasons like construction movement, formwork movement, subgrade movement, that is there. Now as far as cracks occurring after hardening, then there you can see basically there can be structural cracks. The structural cracks may be due to design load, maybe due to creep, and maybe due to accidental overloading. These cracks also further can be classified as thermal cracks. So thermal cracks also occur after hardening. There can be early age thermal contraction. There can be external restraint. So because of external restraints, thermal cracks are appearing. Internal temperature gradients, there can be a difference of temperature, high core temperature and lower outer surface temperature, that also induces the cracks. Physical cracks. So drying shrinkage and crazing, these are two types of cracks are there, and even if the aggregates are shrinkable, then that is also one of the reason of cracks appearing. There can be reasons like external seasonal temperature variations. There can be freeze and thaw cycles, So that also induces cracks. Beyond all this, there are chemical reasons. Cement carbonation, so that also is one of the reason. Alkali aggregate reactions, corrosion of reinforcement. So there are number of type of cracks, and then how to classify. But we can very well classify them because their patterns are there. The reasons behind that can be traced. Their time of appearance also is important. So we will try to look into all these aspects, and we first try to understand all these type of cracks, how to identify that, how to see that whether they are really serious, and if they are serious, what should be the remedial measures. The diagram I am going to show you now is very important diagram. It shows you a number of patterns of cracks, and in a quick look we'll try to see these different patterns, their time of appearance, some logic, some reason behind how they are appearing, why they are appearing, and if any remedial measures, quick remedial measures are there, that also we try to see. Now we see here this crack pattern A. So this is A, this is A. If you see this, these are observed in deep sections, and they are along your reinforcement. So over that reinforcement pattern they are appearing. These are basically plastic settlement cracks, and major reason behind that is excess bleeding, and the remedial measure also should be to reduce the bleeding. So this actually goes to the proper mix designing part. If you look at this another, this is B type of crack. So this B is shown here, and it is shown in the columns also, this arch type of cracks. Here if you can see this arch type of crack, so these are appeared. These are again plastic settlement cracks, and these are again I mean because of the deep section, this, if you want to avoid these cracks, a proper vibration is required, and if any such cracks are there, then it indicates that the vibration is not effective. The energy required for vibration was deficient, proper vibration was not done. So if you observe such cracks, then you can say that vibration was not proper. Next we shall see these cracks. This is the C type of cracks. These are again plastic settlement cracks, and these appear at change of depth in slab sections, beam sections. These sometimes happen due to rapid early drying conditions, and whenever such things are there, this air entrainment can help you. Now all these A, B and C, these three patterns, these are plastic settlement type of cracking patterns are there, and these appear say very early. They appear from the 10 minutes to 3 hours. Within 10 minutes to 3 hours they appear. So one very important thing is that plastic settlement cracks, they are early cracks. They are very early cracks. The moment the concrete mass starts losing the moisture, this appear there. And these are basically related to the placement of concrete itself. So because of the reinforcement obstruction, because of the thickness changes and all, they are appearing there. So we have seen this plastic settlement type of cracks. These are A, B and C. Now let us see the next type, that is, you can see here, this is type D. So type D, these are appearing as diagonal cracks on slabs and roads. These are basically due to rapid early drying, and these are called as plastic shrinkage cracks. Next you can see same way on these slabs, but these are irregular pattern, this E type of cracks. So these are random, and again there is some amount of bleeding is there. So that is the reason. And of course this D and D both cracks can be eliminated or reduced if there is a proper early curing. If the curing is started early and if it is proper, then these cracks can be avoided, E and D. Now if you see next type that is appearing, that is F. So here also it is on the slab surface, parallel pattern of cracks is there, but here the crack pattern is along the reinforcement. This is also a type of plastic shrinkage cracks, and it is appearing ditto and near the surface. So this D, E and F, these are known as plastic shrinkage cracks, and this appear somewhere from 30 minutes to 6 hours of your placing of concrete. Then next to that, let us see the type G. Now here you can see the phenomena. There is a base slab, then this starting kicker joint is provided, and this massive retaining wall is cast. Now this whole mass concrete will have a tendency to shrink, but it is hold in between this your starter, kicker starter. So naturally, because of the shrinkage, this parallel pattern of cracks develops over there, and this is basically out of the external restraint. These cracks are developed. Why? Because the wall cannot shrink as a whole. It is restrained from the base, and that restraint is inducing that crack. There is also the basic reason is being a mass section, there is a excess heat generation, and also if there is a rapid cooling, then this happen. So reduced heat generation is one of the reason. To insulate it can be there, as these two are can be the remedial measures for it. Next to this, if you see H type, so this is here, this is your H type of cracks. These are appearing at the starter, and here also the same. They are similar to G, but only the here they are because of the restraint appearing, restraint of expansion, and that's why here the internal restraint these cracks are appearing. Again same thing, rapid cooling and excess temperature gradients. These are the reason behind. These are basically observed due to the constraint and due to the mass concrete section. Then this your type G and type H, these are called as early thermal contraction type of cracks, and they appear from 1 day to 3 weeks. They are appearing. Now comes your long-term drying shrinkage type of cracks, which appear maybe in weeks and months. So they are appearing on the thin slabs and walls. So you can see here this I type of cracks, and basically this is because of the bad or ineffective joints. This crack actually is supposed to be along this proper jointing pattern, but it is not there. It is randomly appearing here, and also you can see this type of crack pattern is appear here, this type of crack pattern is appear here. So these are basically cracking in the walls and slabs, and these are due to excess shrinkage and inefficient curing. Also this water content in the concrete also play important role, so that need to reduce, and curing also need to improve. So this is long-term drying shrinkage type of cracks. Another, if you see, there is another pattern of crack, this J and K. This are because of the formwork. These are called as crazing, and this happens because of impermeable formwork, rich mixes and poor curing. So improve curing and finishing, that can be the remedy for this. So this appears in 1 to 7 days and may appear afterwards also. Now if you look at this L type of cracks, these are because of the corrosion of the reinforcement. So the reinforcement bar are expanding and they are putting tensile stresses on the concrete, and then the cracks are appearing along this longitudinal reinforcement. These appears in much later stage. So L and M, they are due to that. There are different types of cracks are there. There are different reasons behind that. So this in this master diagram, all the type of cracks in one go, major type of cracks in one go. We can summarize this in a table and have a quick look on that table. So you can see here, this is the type of crack and its time of appearance is also mentioned there. In the figure, the type is mentioned here, its form, location, where it is. So you can find the description to identify that type of crack. And these are some primary and secondary causes mentioned here, that why this crack is there, and also what should be the remedial measures. They are all mentioned. We have already discussed all this in the diagram itself. So to again summarize, I will show you this type of cracks before hardening and after hardening we have seen. And just to strengthen again, we can see this is early frost damage, plastic shrinkage, plastic settlement, and if there is a constructional movement, then formwork movement, subgrade movement. So these are the type of cracks before hardening. Type of cracks after hardening, there can be physical cracks. So shrinkable aggregates, drying shrinkage, grazing, these are the physical cracks. Chemical cracks, corrosion of reinforcement, alkali aggregate reactions, cement carbonation shrinkage, these are chemical type of cracks. Thermal cracks, freeze thaw cycles, external seasonal temperature variations, and early thermal contradiction, that is it can be due to external restraint and it can be due to internal temperature gradients. In the mass sections, there are internal thermal temperature gradients are developed, and there can be then structural cracks, accidental overload, creep, design loads. So as far as structural cracks are concerned, you can see here there are some shear cracks are shown here, and there are here some bending tension cracks are shown here. Now structural cracks are appearing doesn't mean that structure failed. Even under proper design load and in proper design, these cracks can appear. Of course, there are limitations on their particularly crack widths. So if they are within limit, there is no issue, and if they are in a proper pattern. So here being a cantilever, on the top of this there are bending tensile stresses, and this crack has appeared. Here there is a shear force is coming a lot up, so this shear cracks are appearing here. So these are the structural cracks we have seen. Now let us look at the plastic shrinkage basically. So this is the concrete boundary, and excess water is there. It is trying to move out through evaporation, and naturally you have put a volume of concrete in a box, and out of which some ingredients are going out. Water is getting evaporated, so naturally there is a reduction in volume, and out of this reduction in volume, then the cracks are going to develop. So because of this reduction in volume, what is happening? These cracks are developing there. So you can see the different patterns. There can be the diagonal pattern, there can be random pattern, or it can get aligned with the reinforcement. So plastic shrinkage patterns, they appear on surface, and you can see all these type of patterns are there. These are not structural cracks. Very important thing, this pattern of plastic shrinkage pattern of crack appear. This appears much earlier. I mean, if you see the table, these appear 10 minutes to 3 hours, or at the most you can say 30 minutes to 6 hours. So you have not de-shuttered there is no structural load has come on it, no structural action has developed, there is no proper bond developed between the reinforcement and the structure itself. So in this case there is no need to connect these cracks with the structural cracks. So look at this pattern carefully. For from site people, you always consult, or if you are on site you always note down that what is the time of appearance of these cracks, at what time they appeared. Not every crack is a structural crack. So these are all plastic shrinkage cracks you can see here in the diagram. If you want to see some examples, you can see it here. So see this pattern what we have seen in the diagram, it is appeared here. This is the plastic shrinkage type of cracks. So these crack patterns can be seen very easily on large slabs. Sometimes it is along the reinforcement you have seen. So here you can see it is along the reinforcement. In today's lecture, let us stop at this point, and in our thank you very much for listening to this video. If you find it useful, please like, share and subscribe.